I need to apologize. I was sick for the for the whole week, and I have recovered mostly. My voice haven't quite recovered. I think I can I can do 20 minutes with proper support here. But I apologize if I'm raspy. Hey, so. And my talk is based on 2 or 3 research projects that I have with Yanis Bakos and Christoph Müller-Bloch. And those are different types of research on permission blockchains. Actually, it's research on commercial use of blockchain, and it quickly turned out that commercial use of blockchain mainly means permission blockchains. And let me say why. I mean, not all, like there are some singular examples of not, but if we want to do large-scale research, it turns out that we should focus on permission blockchains. So while everything started with Bitcoin, right? We know that, and I'm going to go through a couple of characteristics of Bitcoin, not because I want to inform you. I just want to create a reference point because I know that you're already informed here. So bear with me. So Bitcoin as a distributed digital currency system. So it's focused on digital currency. And it's a great system, innovative system, because it is at the same time distributed, happens to be transparent. It's permissionless, both for validators and for users. Nobody needs to seek anybody's permission. This is like this holy grail. And it is secure, meaning it's consistent, and achieves all this without any trusted third party. So this has been like really an interesting combination of features, and it was difficult to create a system like this. For a cryptography community has tried for at least for at least a decade and a half before, maybe longer. So we talk about Bitcoin system as a trustless system because we don't need to really trust anyone in the system, and the system is still this completely distributed, permissionless, and still secure. And of course, it's like there's all this market design things that happen, and we don't know whether Nakamoto really thought hard about it and eliminated all other options or stumbled upon it, but it works really well for practical purposes. We don't need to trust anyone. Trustless system, and it has been repeated many times. Now, what it does, let me kind of like point out, is it is not the first distributed and permissionless system that works, because we had Napster before, and we have BitTorrent, and we have other distributed systems, and they work, right? But this is the first system that solved double spending problem, very particular problem, in this distributed, decentralized, no trusted third-party system. So this is the innovation, not just those 3 pointer, not just those 5 features, but this is in the context of double spending. Now, why this is important is because this is an effectively reliable transfer of value. And if you think about file sharing, there is no double spending problem in file sharing. To the opposite, we want to create as many copies as possible in file sharing, peer-to-peer file sharing. But if you have anything of value, by the definition of value means scarcity, and you want to prevent duplication, because when you duplicate it, it loses its value, then you need to solve double spending problem to transfer value. If you want to transfer value digitally, until now we had the big banks and other centralized parties keeping track of it. Okay, so now everybody around 2016, everybody got very excited. Could we use it more generally? Could we use this reliable transfer of value more generally, not just in the context of cryptocurrency, but in the context of real estate ledger, in the context of financial transfers? Big banks started thinking about creating shared ledger to write all the transactions, because banks are spending a lot of resources on reconciling their individual ledgers between each other so that they all agree. If we have one common ledger, every transaction recorded is automatically reflected in everyone's individual ledgers. It solves the problem of having T plus 3 settlements. Real estate ledger, if we can have real estate ledger on blockchain in Peru, presumably it's going to solve all the property problems. I mean, we know it's a little bit bigger than this because blockchain is not solving institutional problems. It's a technology, so it's solving technology problem. And if institutions are not there to back it up, they're not. It's not going to be enough. But can we do other things with blockchain? And this is how it kind of started. It was attractive because it was distributed. Multiple parties can write into the ledger, right? This is what Bitcoin presumably is. Anyone can participate in writing into the ledger. Well, it does not mean that anyone can go and write into Bitcoin's ledger. There's some mental skip in there, because it just means that anyone can participate in the system where they compete for the right to propose a block that could possibly be entered into the blockchain, right? But somehow that got mentally shortcut. And the system is secure without trusted third parties. So it seems like anyone can write in it, and it still works and is secure, right? So it became this, like it skipped from the previous slide to this magic now, because people were saying it's cryptographically assured to be immutable, right? We know it is not true, right? Because Bitcoin system for practical purposes is immutable, meaning it's secure and it's consistent, but it is not just cryptographically assured. There's this whole market design aspect that there were like 2 previous sessions devoted to market design in mining and making sure that this incentive systems and also what Kathy was talking about, whether it works. So yes, we have, for practical reasons, Bitcoin being immutable at the cost of mining, at the cost of proof of work. It's not just cryptography, it's not just public-private keys and that are going to get us there. It's not just caching is the longest blockchain rule and all the other elements that are game theoretical elements. They kind of got forgotten a little bit. And I will say why it matters. So the expected benefits from the industry were, okay, we are going to save on costs. Again, if you ignore cost of mining, now all the work is done in distributed way. Nobody we don't need a central party to keep the ledger, should be cheaper. If you think for a while about all the replication, may not necessarily be true. But it seems like it is going to improve our collaboration between independent parties, even when they have conflicting objectives. Look, Bitcoin is great because it creates this trustless system that everybody writes into the ledger. Nobody needs to trust anyone. And yet it creates this consistent system. Okay, so can we get it? Can we get it for other aspects, for other uses than just cryptocurrency? And I mean, we can. We have been trying that for a while with Ethereum, but. Really, when large companies are thinking about it, they quickly say, okay, let us try blockchain. It seems to be this great distributed idea. We want to use it. It should be better, save us costs, improve collaboration and coordination. So every time they look at Bitcoins, and this was back in 2016, they look at Bitcoin's blockchain and other permissionless blockchains, really permissionless blockchains, they quickly figure out that this is like a non-starter. They can't just take Bitcoin and run with that, not even just Bitcoin's blockchain. So first of all, they don't need cryptocurrency. Right. Second, they can't really accept probabilistic settlement. So blockchain is supposed to be cryptographically assuring immutability, and yet you always have some probability that you are going to end up on orphaned chain, according to longest blockchain rule, if you have proof of work. This probability is decreasing with time, but the settlement is always probabilistic. And Wall Street, for example, could not really deal with that, even on the 2 or 3 blockchain deep forks, okay, accidental forks, right? They don't really want the costly validation that comes with proof of work, and they wouldn't want to pay for it. Right, and they couldn't really like every mention of Bitcoin's blockchain, they would say, but 1/3 of miners is in China. Would you trust validators who are in China with our system? And if you don't know who the validators are, one presumption in blockchain system is that the validators are not coordinating and not collaborating, which we know is kind of violated. So if you don't know who they are, you are actually, you may be legitimately worried about the system, because once you start putting higher and higher values on it, the incentives for the validators to collaborate on validation of fraudulent transactions may actually increase. Okay, and they actually don't want transparency. We always say we want transparent systems. The first talk in the other room was that transparency is great. Transparency is at best ambiguous in the industry world. So imagine transparency where your competitors can see all your transactions. Right? You don't want that transparency because trade secrets are difficult to keep. Moreover, antitrust authorities wouldn't like this transparency. Like we think that maybe government would like this transparency. No. They would like to see this information themselves, but they would not like the market to see this information. Why? I mean, there's a good legitimate reason. It's not just evil incentives. It is because if you have such full transparency, collusion is much easier to sustain. Companies can threaten each other if they step away from tacit collusive agreement, and I can see every time my competitor deviated and offered someone lower price. If I can see that and I can punish them for this, the collusion can be perfectly sustained. This is bad from the antitrust side. So we as customers tend not to think about it, but this excessive transparency may actually be hurtful for customers. But at the lower level, the firms don't really want other firms to know what they are doing, so they wouldn't want to have the full transparency. There's another problem when it comes to using blockchain for everything else than native cryptocurrency. So if it's Bitcoin or Litecoin or any native cryptocurrency, it's born on blockchain, it lives on blockchain, only on blockchain, and it doesn't represent anything else outside of the blockchain. Right? Now, the moment we start using blockchain for digitized or digitally represented other assets, somebody needs to put this information on the blockchain, and this is what we call gateway problem. And we need to trust this party to put this information on. And also, the real life assets may split, disappear. Some things may happen to it. We need to have a trusted party that is going to reflect those changes on blockchain. And moreover, if they make a mistake, we need to have a way of recourse. So Bitcoin's blockchain is not going to do that. So these issues were resolved by permission blockchains, where there are only a limited number of known validators, and this is how commercial application of blockchain is being used. Now, there's probably, I'm expecting half people in this room that will say permission blockchains with limited number of known validators, those are not blockchains. Okay? So I'm estimating half the people. And really, it kind of goes back to the issue that I don't think we have a definition of blockchain. I haven't yet seen one definition of blockchain that could be consistently applied across all the uses of the term. So there is a big disagreement about what is called blockchain. And yes, I'm happy to say that we are not really talking about blockchains here. We are talking about applications called blockchain by the industry. And then the question is whether we want to talk about it in an environment like this and in a group like this, or are we going to kick it out altogether? And we may decide to kick it out, but this is something for research, right? This is a research agenda setting meeting. Okay. So also the rhetorics changes, because before we were talking about trustless system. Bitcoin is a trustless system. We don't need to trust anyone. Now we have distributed trust. So now we have a whole bunch of trusted validators, but because we have 5 of them or 8 of them or 28, we don't need to trust each one of them fully, because they will kind of need to check and balance each other. So, in one of my research projects, we basically collected the commercial uses of blockchains and different projects, and we looked at the most common applications. We also looked how they are doing it and whether this actually applied and how quickly they abandon it. A lot of it gets abandoned. So there are four main uses of blockchain as we have found. One is kind of supply chain and movement of goods. And the very first example was putting the transfer supply chain of diamonds on blockchain. It was an offshoot of the fork of Ethereum blockchain, and this was Everledger. And all the way, there's a number of those applications, all the way to IBM Food Trust and IBM blockchain solutions. I can talk. I can talk a long time about those applications, but I only have 5 minutes. So the other one is international transfer, generally transfers of money, but especially international transfers seem to be very appealing because despite the rhetorics of evil banks, domestic transfers are working pretty well, and nobody seems to find it worthwhile to deal with the user interface for other reasons. So it's international transfer, it's Ripple, and there's a number of commercial uses. Like it was Zoom for a while. I mean, some of them, like I say, they get abandoned. So those seem to be like quite reasonable applications of blockchain because you can see how we would have movement of goods or money that we want to track. And yes, once we have trusted validators, we can have consensus based on voting, and we can kind of do all this hashing and blockchain in this closed system, and we're tracking something. Now, the other two applications are kind of a mystery to me. One is as a reference data repository that is used for certification and authentication. And the other is for voting. Is voting on blockchain. And basically, you vote once, but you as a voter want to make sure that while your vote is anonymous, you can check that your vote is counted and counted as a correct vote in the database. So you get your key, and then later you can check here. But you're doing it only once. The same with data repository. You're putting information only once. It's a mystery to me. Why do you need a blockchain for that? So we will see how those applications are going to go on in the future and whether they're going to be used. Now, when permission blockchains and commercial applications of blockchains are considered, what we see is that there are two dimensions of control that need to be, especially when we talk about those permission blockchains, we need to think about. One is a control of validation, right? How many validators do we have? And what is their relative power? Are there like 3 equally important validators? Are there 5 validators, but one is more important than the other ones? They may be very skewed. It may be more or less distributed, actually. And the other is, how tight or loose is control over validators? Who is choosing who are the validators? How difficult it is to become validator? Can the validator status be revoked? Like, can the validators be punished by being kicked out? And because it reflects what are the strategies for holding validators accountable. Notice Bitcoin does not need any of it because it's anonymous and it has to have this control with each other. So we can basically put our examples, many examples on this in this two-dimensional space. But what I wanted to kind of point out is that we may have certain permission blockchain being more decentralized than Bitcoin, right? If we look at how distributed the control of validation is, Bitcoin will have fewer, dominant pools. And like we said, that how many pools are in a different talk? How many pools dominate 30% of computational power? It is much less than the 27 validators in Libra. So we can construct permission systems that are more distributed than permissionless systems, because permissionless systems are designed to be as distributed as possible, but what happens in equilibrium is actually a different thing. But even if they are more decentralized, they are controlled much tighter than the permissionless systems. So this is something that I think it's worth our attention, that those dimensions are different. We can have a tight control and a decentralized system, and we have a loose control and quite centralized system. So it's not the same. Now, how much time do I have? Okay, so let me see whether it makes sense for me to, definitely does not make sense. There are digital currencies. So let me just say that, of course, digital currencies are not necessary for blockchain applications, but many blockchain applications use tokens in their systems, even the permission systems. And we divide them into 3 different types. They are either auxiliary, provide liquidity. They are utility tokens that may provide flexibility in pricing the good, as well as commitment in how the good provided by the platform will be priced. So utility tokens are very often tokens that are needed to participate in the platform. You first need to buy a utility token to have access to service or a good on the platform. And they are different. There are some platforms that will have both utility tokens and payment tokens. Having payment tokens, for example, allows for automatic payments on the platform without dealing with the banks, which may be useful. Of course, having those tokens adds additional complexity, because having the tokens is typically on top of a blockchain that is permission blockchain. It's not the same construction as Bitcoin blockchain, where in fact it's not that the Bitcoin is put on top of a blockchain. Blockchain is the outcome of Bitcoin protocol, right? So people sometimes portray as this blockchain. Bitcoin is blockchain with Bitcoin unit put on top of it, and we know better. You have a Bitcoin protocol, and as a byproduct, we end up with a blockchain, certain properties. Okay, so. With that, I will, so sometimes it doesn't make sense to really use the blockchain. The real benefits of the blockchain, let me just leave you with one thought. So very often when you read the justification for why blockchain is so great, it's like, we had this terrible manual process and we lost the files. Yes, of course, you need digitization. Doesn't mean you need blockchain, right? Now we have all the data in one platform. Sure, yes, you need standardization. You need to put all data on one platform. Does not mean you need blockchain, right? But what happens is there is enormous hype around blockchain. And it may be not the best technology to use for whatever application commercially the companies want to use. But every time you need to you need to get this collaboration, you need to get multiple parties, multiple independent entities on one platform. It is like, it is Herculean job. You try to get them on one platform. Every time one becomes dominant, somebody does not want to join because it's going to be dominant platform and exert all the rights just on purpose. Let's say government mandates a standard. We don't want to get on the government. Government is ruling our industry. We don't want that. IBM is proposing a standard. IBM is going to take all our rents. We don't want to do it. Nowadays, you know, for the past couple of years, you say we are using blockchain. Everybody says, oh, we need to use blockchain as well. Let us get on it. Because of the hype, it actually created this coordination device that allows different companies to jump on the blockchain bandwagon, creating those unified systems that do provide more efficiency. So in fact, creating one blockchain and centralizing activities around this one blockchain, going contrary to all this decentralization, provides more efficiency for completely different reasons. I still think it's worth studying, right? So we don't really need blockchain for most of that, but with existing blockchain tools, like IBM already built that, So now it's easy to use blockchain, for example, for voting on blockchain, which doesn't really need blockchain. Right? So we end up with these inefficient solutions because the solutions are already there. So I kind of wonder how it's going to develop and which of the applications are going to be shed by the market and they're not going to sustain the competition, and which of them are going to stick around in this blockchain fashion and, let's say, applications that the industry calls blockchain. Okay, thank you very much.